So in this problem, I'm given a statement about the standard deviation in the lengths of response times. So just like I would do with any hypothesis test, the first thing that I'm going to do is identify my claim, which again is in terms of the standard deviation. Now we always test in terms of population parameters. So population standard deviation is a value of sigma, and the claim is that this standard deviation is less than 3.7 minutes. So to set up my test, of course, I'm going to look at the opposite of the claim. The claim does not contain equality, so when I flip that to greater than, I'm going to actually make this greater than or equal to, because one of the two statements must have equality. Now, the statement that has equality becomes my null hypothesis. So greater than or equal to will go to the null. The statement with inequality, which is less than, will go to my alternative. And so that means for this test, my claim, what I'm testing, is in the alternative hypothesis. All right, now, I'm going to go back and pull the sample data because that's what I will use to run the test. And all I need to know here is the size of my sample and the point estimate, which would be the sample standard deviation. So this is coming from a sample of size 9, and that sample has a standard deviation, S, of 3.0 minutes. All right, and the last piece of information I need is that level of significance, which is going to be 0.05. All right, so from here, I'm going to use that level of significance to get my rejection region and my critical value. Testing for variance or standard deviation is always going to use a chi-square distribution. So I'm going to sketch that chi-squared curve that's always skewed to the right. Now, to shade my rejection region, for any hypothesis test, I look back to the alternative hypothesis, H sub A. And because that contains less than, I know this is going to be a left tail hypothesis test. So that tells me that I'm going to shade my rejection region somewhere back here in the left tail of the curve. And we know, just based on all the things that we know already about hypothesis test, that the level of significance will give us the area of that shaded rejection region. Now, if I'm going to use the chi-square table to find the critical value here, the chi-squared table always works in terms of area to the right. So what I'm going to need to do here to find this particular value is take the area that I'm given, which is 0.05, and subtract that from 1. All right, and again, this is solely because when I go to the chi-squared table, what I need to make sure I have is an area to the right, not an area to the left. So just for a right-tailed test, or sorry, just for a left-tailed test in this case, I'll have to take that level of significance and subtract from 1. So I'm going to take that 0.95 to my table, and I'm going to take my degrees of freedom, which are always going to be in -1. All right, so I'm going to go to my chi-squared table now. All right, and again, what I'm looking for here, area to the right is 0.95. All right, and again, that's always what we look up in the chi-squared table. And degrees of freedom here in -1 were 8. So that shows me that my critical value for this test is going to be 2.733. All right, so I'm going to place my critical value right there, and the rejection region will be any values less than 2.733. All right, now that I have my rejection region, I'm going to calculate, again, this is always called the standardized test statistic. Now, so far we've looked at test statistic formulas for mean, and for proportion. When we're testing variance or standard deviation, we calculate a chi-squared value, and the formula is always n minus 1, the degrees of freedom. We're going to multiply that by the sample variance, s squared, and we're going to divide that by the population variance, sigma squared. All right, so I've got everything that I need here. I'm going to take information from the sample, right, sample size minus 1. Now the sample gave me standard deviation, which is an unsquared value, so because this is in terms of s squared, the variance, I am going to have to square that here. And the same thing for when I'm dividing. This formula is always in terms of variance, which is sigma squared for the population. So since I'm testing in terms of just sigma at 3.7, I'm going to take that value that I'm testing and I'm going to square it here. All right, and that's going to give me a standardized test statistic of 5.259. All right, now, at this point, what I always do with my standardized test statistic is I take it back to my rejection region, and I look to see if it falls in the shaded rejection region. And again, you just look at this horizontal axis like a number line. So my rejection region is 2.733, and anything to the left of that, less than, obviously this is not going to be there, right? 5.259 is going to be somewhere to the right of 2.733 because it's greater than, and so because it is not in the shaded rejection region, this test will not be able to reject the null hypothesis, which is stated as failed to reject the null hypothesis. Now, last thing I need to do is just interpret that decision based on my claim. Because the test failed to reject, which is what it's set up to do, that always means there is not enough evidence to make a definite conclusion. All right, that'll always be the case when you fail. Now, because in this test my claim was not in the null hypothesis, it was in the alternative hypothesis. When the claim is in the alternative hypothesis, the test is not looking to reject the claim. It's actually looking to support the claim. All right, again, anytime your claim is in the null, the test is looking to reject. Anytime your claim is in the alternative, the test is looking to support, because that, of course, would be the opposite of what's in the null.